Hello guys, welcome back to a new video. This side I'm Shafi Jami, and in this video we are gonna be converting a normal video and displaying it on terminal window like command prompt or something like that. So in this video is gonna be like so much short. So I expect you all to understand the things that I say in short. So first of all, I expect you guys to make a empty project and then go to general and additional include directories and add like your include OpenCV, include folder directory, then go to Linko and then Linko general and then there add your what do you say library directory in additional library directories OpenCV library directory and then go to input and there if you are using debug add the debug library or else just the normal library. So this was my debug library here and then debug library name here we get our in library directory name and here is the additional library directory of OpenCV build OpenCV you can see linker and then input our debug library and this in C++ we are going to be including our include library and then this is what I expect you and then go to source your what do you say working directory and there add a video of your choice and then the DLL debug DLL in the working directory so the app works. So now let's just get on with our code. So we are going to be defining a gradient here. See, if you want to have a what do you say it? If you need a detailed video, I also uploaded it. It is about of 30 minutes, so you can understand everything. And if you already are enough capable of understanding things, then you can see this. So here we are going to be assigning a ACSII gradient. This is the most deepest character and then here we get our lightest character like what do you say brightness dark and least bright. So here we get a dark and bright. This is what we get and then we get our function a function to which is pixel to ACSI. Here we get a pixel value of brightness from 0 to 255. How much it is bright? Then we get our size minus 1 divided by 255 to get the index of the value that we are gonna character that we are gonna be returning. Then we return that character. So just what we do here is just from a grayscale pixel we just need its value like 0 or 255 how much bright it is and just return accordingly. Then we are going to be making a new function which is inline void move cursor top left. So this just moves the cursor top left like right here in the terminal it would just move it to top left like my cursor would be here it would move it to top left to right. And then we are going to be starting our main function. Actually again I'm saying that if you are only capable of understanding things that I have been explaining then only see this video. Otherwise, go for the detailed explanation. You would be able to understand what I'm doing. Actually, if you are not capable to understand it right here, then here we are gonna be starting a video capture of the video with the file that we have, and then if capture is not opened, I'm just pasting this here because if I go for writing, it would take some minutes and the video would be become long. So here you can see if the capture is not open, then just give a error and go back. Then we are gonna be defining our width of the ACII, then aspect correction because the text that we see is not in not a square. The text that we see characters are not square, they are taller than they are wide. So we apply a correction factor about 0.55 to then we get our aspect correction, then we get our video height and then video width and then video height. Then accordingly to video width ACI width and width height we decide our height of the ACII. Then now we are going to be making a three picture frames. One is frame, one is resized, and one is gray. So now first at start, we are gonna be clearing the screen, the terminal window here. And then now we are gonna be getting our while loop. Then we are gonna be getting our while loop. And here we are gonna be reading our frame from the capture, from the video capture. We are gonna be reading it into the frame. And then we are gonna be converting it to like first, we'll be resizing it according to the width and height we decided. And just we are gonna taking raw from frame and saving it the resized image to the resized mat. And then we are gonna be converting our color. You see, we convert color from color blue, green, red to gray in CV, and just taking it from first we get a raw, resize it and save it here. Then we just convert its color to black and white and save it here. This is what we do here. Then we cursor to top left, move cursor to top left. We just move our cursor to the top left of the like terminal window. And then now we make our string. Here we make our string. So we make a output string and reserve the height into width into 20, because the height and width would be the total number of pixels in our video, and then into 20 because each character would not be just a character that we see on a screen. It would be surrounded by color codes. So the like color codes at before and after it. So it would be like around 15 to 18 characters long, but we just for being safe, care it 20. Then we get our loops over each row, vertical direction, each row. So then we get it, and then we get another loop, which is another loop about it, in which we get our, no, not this loop, not this loop, not this. Mm, After that, we need a column loop, so that we just iterate over each the column in the current row. It's just a row and then column, each column in the row. Just like in this column, do all, in this column, do all. It's like that. So we get our two loops. You guys are able to understand, I think, this. First of all, we just reserved it, and then we just do this to iterate over each pixel, each and every pixel, this pixel, this pixel, this pixel, this pixel, this, each pixel in the video. Done. Now, what we need to have is one more bracket, and then now here we get our pixel color. So here we get our vector 3b color. So resized frame, in resized frame, what is the color of this pixel y and x point at the in the resized frame? What is the color of this pixel? What is the color of the pixel? Just understand this. This is important. In the resized frame, what is the color of the pixel at this point? It's like that. So it just gives us a in this manner, just gives us in this manner. Blue, green, and red usually get RGB, but here we get BGR. Then now we just get our pixel value from grayscale, which is like gray is the grayscale version, the same frame. Here, just have a look at this. This is a grayscale version of the same frame, and this gives a single value 0 or 255 for white. This is just for brightness. And now we are gonna be just making it in the ASCII code. So here we just what we just did is, let me explain it to you. What we just did is like ACSSI chart. We didn't make it. Wait, we just first need to make this. Before this, we need to add one more line of code, which is convert our. So right now we already have got our pixel what is the pixel, like 0 for black and 255 for this. Then convert the pixel. Here we get our 0 or 255 and we just get the index and return one of these characters here. Then now we need to make a string of that thing. So is what we do is just like have a look at this. Then you will understand it. Have a look at this. The 033 is the escape character for terminal control sequences, and we need to provide value in this form. Like 38.2 is constant for our case. 38.2, we do not need to edit this much. 38 semicolon 2 semicolon. Then we provide our RGB. So here we provide our R, which is color 2, then G, which is color 1, and B, which is color 0. So we just provide it, and at last M is constant. So for red color, we would be providing like 033 38 semicolon 2 semicolon. This is the constant. And last M is the constant. M last is the constant. We just provide 00255 and it comes the as red color in the terminal. So after we have done a column, then just reset the color at the line end. Reset the color at the line end the line and reset the color. So uh, reset the color and end the line so that we don't just write each frame in one line. We just change our line according to it, and then we just flush it. And why do we flush it? Let me just tell it to you. We flush it because without STD flush OS might delay the output and your ACI video would appear choppy or late. And like it forces the buffer to be printed immediately without rather than waiting it for fill. It's like that. Then we just make our CV wait key. And most of you are experts and would understand what this is. 100 millisecond divided by 60 means 60 FPS. Otherwise, if I did 30, then it would mean a 30 FPS right here. And then just it's like that. And just at last, we release the memory that we have taken and just return a 0. So it's as simple as it. And like if you didn't understand anything right here, you can comment down. I would take care of it and make sure you guys understand it. And if you need a more proper explanation of all the lines here, you can just go for my explanation video. I will give the link in the description. It's of about 20 minutes and you can watch that. So let's just test this out. Here you can see we have got our video. As you can see, it's here. You can see it's all the video. And make sure to like this if you have all learned something new, and just drop down if you need some more library things and etc. etc. Thanks.